So we know if we toss a ball in the air, it's going to follow a path something like that. And we know that this shape is called a parabola. We can model a parabola with a quadratic equation, and that's the exact equation you can see right here. So in this case, the equation is negative 10x squared plus 20x plus 1. Don't worry about this stuff over here. So as the ball falls through the air, we can use an equation to predict where that ball is going to be. So in this lesson, there's a few things we need to learn about parabolas, about the different aspects of parabolas that are going to be very useful to us. So let me start by pausing this. By pausing this, I'm going to bring it to the end there. There. So for this parabola, there's a few key locations we need to know about this parabola. Number one is there's this point up here at the top of the parabola. We call that point, sort of the point where the parabola turns around, as the vertex. Right? Now, there is another thing that we need to know, and that's called the axis of symmetry. You might notice about a parabola is that it's symmetrical. What happens on one side happens on the other side too. Parabolas are always symmetrical. And what we can call the line that goes down the middle of the parabola, this line here, it's always a vertical line. We call this the axis of symmetry. So it's the line that goes straight down the middle of the parabola, and it always goes right through the vertex. Okay? The last point that we need to know for today is called the Y-intercept. Now, we know the Y-intercept from lines, equations of lines. It's the same thing. It's where the parabola crosses the y-axis, and we call this the Y-intercept. With these three pieces of information, the Y-intercept, the vertex, and the axis of symmetry, we can actually get a pretty good idea of what a parabola is going to do, and we'll be able to sketch it based on the equation. So that's what we're going to do. So let's move over here to the lesson. First of all, if we're given a parabola, can we list the vertex, the axis of symmetry, and the y-intercept? So the vertex we know is that point that's at the top of the parabola, right? So this is the vertex here. So let's label that first, vertex. Now, when it's saying give us the vertex is just a point. So we need to put down the coordinate of that point. Well, the coordinate of that point, we just look at it, x and y. So it's going to be 2 over and 5 up. So the coordinate of the vertex, in this case, is 2, 5. And that's the same thing I'm going to write down here in this blank, 2, 5, because it's just a coordinate. The next thing we need to know is the axis of symmetry. So remember, this is the line that goes straight down, vertical line that goes straight down the center of the parabola. So that line looks something like that, right? It goes through the vertex straight down the center of the parabola. Now, the equation of the axis of symmetry is what's the equation of that line? That's what that means. And you might remember, a vertical line always has the equation x equals something. Well, in this case, the vertical line goes through 2, right? It's at a location of 2. It's at an x value of 2. So the equation of the axis of symmetry is just x equals 2. Or I'm going to write it down here as well, x equals 2. Because that's the x coordinate of that line, that vertical line. And then lastly, the y-intercept. We're asked to find the y-intercept of this equation. And the y-intercept is where it crosses the y-axis, right? This here is the y-axis. This is the x-axis. So the y-axis, it crosses the y-axis down here at -3. So the coordinate of that point is, well, it goes 0 left to right and down -3. So that's the coordinate of that point. So we would put 0, -3. Sometimes you can say that the y-intercept is just -3. That's where it crosses the y-axis. But it's pretty good to understand how to create a point with that. So that's 0, -3. So I want you to pause the video, try the your turn question yourself, unpause it when you think you've got it, and then I will reveal the answer. Pause it now. So there you go. There's the solution to this. The axis of symmetry is at x equals -2. The vertex is at -2, -3. And the y-intercept is at 0, 5. So you'll notice in this case, the vertex can be at the top or the bottom of the parabola, depending on which way it goes. So here, the vertex was at the top. Here, the vertex is at the bottom. So now what I want you to do is I want you to try the same thing for these 4 questions. Pause the video here, try them all, and then I'm just going to put the final answers down on each of them. Okay, so pause it here and try it. So here are the answers. So look over your work, check it yourself. One's a little bit tricky. This one down here, the y-intercept isn't on an exact value. It's close to 3, but it's just a little bit bigger than 3, so I just put 3.1. That's just an approximate value. The last one's also a little bit tricky because the vertex is right here, right? But that is also where the y-intercept is, because this is the y-axis, right? So it crosses the y-axis at the vertex as well. So that's the answer for both of them, which is 0, 0. And the equation of the axis of symmetry, that vertical line, is also at 0. The next part of this video, we're going to talk about how to sketch a parabola from an equation. Now, the equation that we're going to use is going to look like this: x squared plus bx plus c. So we could have any value in front of the x here, or any value here at the end as c. You'll notice there's nothing in front of the x squared, and this process only works when that's the case. We call this form of a parabola, we call this standard form. I'm going to call it a quadratic, the standard form of a quadratic. Okay? So these equations here are both in standard form because it's x squared plus something x plus something. So in the first case, it's x squared plus 4x minus 1. How are we going to sketch the graph of that from the equation? This might look a little bit tricky. How we've done this in previous lessons is we've come up with a table of values, right? Like we've come up with a table of values, we've put in x and y, -1, 0, 1, 2, and then you find values for each one of those, right? And then you could use that to plot the graph of it. I'm going to show you a few little shortcuts here that's going to make it a little bit easier so you don't have to plug in quite as many points. So first I want to point out, when we look at this equation, let's zoom in here. When we look at this equation, it's there's part of it that looks like a linear equation, right? If we just forget about this x squared for a second, notice how the second part, 4x minus 1, looks like a linear equation. And in a linear equation, you might remember the last number, the number that doesn't have the x with it, that was the y-intercept. And that's actually true of a quadratic too, of a parabola. The y-intercept is the number by itself. So all we have to do the y-intercept is going to be at 0, -1, because in this case, it's a -1. So what we do is, on the graph, we're going to go down here to the graph, we're going to plug in a y-intercept of 0, -1. We're just going to put the point at -1. Okay? So that's the first thing. How can we find these other two things, the vertex and the equation of the axis of symmetry? Well, there's actually another trick, and that is this b value here, this value in front of the x. That tells us a hint about the axis of symmetry. And the pattern is actually this, that the axis of symmetry is always x equals -b/2. So whatever that b value is, we just make it negative and we divide by 2. That will tell us the axis of symmetry. So in this case, -b, so b is 4, right? So in this case, b is 4. The negative of that is just -4, and then we divide by 2. So we're going to do -4 divided by 2. So the axis of symmetry is going to be -2. X equals -2. So on the graph, how do we draw the axis of symmetry? Well, at -2, all we got to do is draw, I like to draw it as a dotted line to represent that axis of symmetry. I'm going to label it too, axis of symmetry. So right now, we know that the parabola goes through this point here, the y-intercept, and it's going to be symmetrical where that axis of symmetry is. So the next thing we need is the vertex. If we know the vertex, we can plot the vertex and then just plot the equation of the parabola, right? So how do we find the vertex? Well, the trick here is that we know the vertex is on the axis of symmetry. It's somewhere here, right? So because we know that, we know the x value of the vertex is -2. If we know the x value of the vertex is -2, we can just plug -2 into the equation. Whenever we plug a number into an equation, it's going to give us the y-coordinate, right? So if we know the x-coordinate of the vertex is -2, we just plug that into the equation, and it will tell us the y-intercept. Or sorry, the vertex. So I'm just going to make a quick note of that. Plug in axis of symmetry into equation. So how that looks in this case is y, well, our equation, I'm just going to write it out. X squared plus 4x minus 1. I'm just going to replace the x's with -2 because that was our axis of symmetry. So it's going to be -2 squared plus 4 times -2 minus 1. Notice how I put the -2 in brackets, and that's important because -2 squared, we gotta include the brackets, because if we're just doing -2 without the bracket squared, that's going to give us -4. But -2 times -2 should be +4. So this is going to be 4 plus -8 minus 1, which, when we do that in a calculator, it's going to be -3. Right? I think I did that right. -8, -9. Nope, that's wrong. Hopefully you caught my mistake. That should be -5, right? Let me erase that. -5. Okay, so what that tells us is that the y-intercept, or the vertex, is at a y position of -5. So I go down to my graph, and my axis of symmetry, we know the vertex is on the axis of symmetry at a value of -5. So down here at -5, I'm going to put in my vertex. So my vertex is basically at -2, -5. So now that I know my vertex and I know it goes through this point, what I'm going to do is I'm going to start from my vertex, and I'm going to go through with a nice curve like a parabola. I'm going to go through that y-intercept. Then because that's the axis of symmetry, I can repeat the same thing on the other side. See that? So I just mirror it on the other side. There, I'm done. I've drawn my parabola. So just to summarize here, the vertex, the axis of symmetry was x equals -2. And the vertex was at -2, which is the axis of symmetry, and -5, which we got from plugging into the equation. There you go. So I want you to try the next question yourself. Pause the video here, try it yourself, unpause to see the solution. So in this question, I got that the y-intercept was at 0, 5, or sorry, 0, -5. No, 0, 5, that's right. Which is from this value, right, the c value. The axis of symmetry I got by doing -b/2, and it was just -6, and a negative makes a positive, so it's just 6/2, which is 3. So the axis of symmetry was x equals 3, and then all I did is I plugged that 3 into the equation to give me the y value, which was -4. So our vertex is at 3, -4, so I plotted those things. And then to sketch the graph, remember I'm going to start at my vertex, and I'm going to go through my y-intercept. Something like that. That wasn't very good. I'm going to erase and redo it. So I just want to show you here, this isn't easy to draw the parabola. Sometimes it takes a few tries to get it right. So make sure you're working with a pencil if you're working at home. Like that, something like that. And then I just repeat the same thing on the other side. I made it a little bit pointy down here. It shouldn't be this pointy. It should be a little bit more rounded just for your information. But that's what the parabola looks like. So now what you can do is you can try these 4 questions yourself. I'm going to post those solutions so that you can check your answers as you do them. You'll notice I didn't put the box for this, right? Vertex's axis of symmetry, Y-intercept, but you still got to find those things. So you should probably use this little space here to show your work to find the axis of symmetry in vertex before you graph it. Okay? Good luck.